All right, we're looking at another parametric equations problem here with bugs again. In this case, the bug starts at the point 2,3 as a 0 seconds. After 3 seconds, he's reached the point 6,5. After 6 seconds, he's reached the point 10,7. And after 9 seconds, he's reached the point 14,9. So we're going to go over here and record these values in a table. So let's see. At 0 seconds, the bug is at the point 2,3. We're going to leave one open like we did before. At 3 seconds, the bug is at 6,5. At 6 seconds, the bug is at 10,7. And at 9 seconds, the bug is at 14,9. So it looks like every 3 seconds, the bug's x coordinate increases by 4, and the y coordinate increases by 2. So let's see, 12, C is 3 seconds later, so that'd be another 4 in the x direction, so that's 18, another 2 in the y direction, that's 11. And then 3 seconds later, it's going to be another 4 in the x direction, that's 22, another 2 in the y direction, that's 13. And now we want to come up with an equation like we did before. So to come up with an equation, we want to look back and figure out what it is for 1 second of travel for the bug so that we can plug in any number of seconds. So like the pattern we have right now only works if we plug in seconds that are multiples of 3. And even then we have to kind of, work our way down the table. So let's see what we can do for 1 second. All right. So let's see. From 0 seconds to 3 seconds, the bug traveled from 2 to 6, so that's 4 units. 4 units in 3 seconds, so that means that every 1 second, the bug travels 4/3 of a unit, right? Which is 1 1/3, but I like the improper fraction better. That's easier to work with. Let's see, and in the y direction, the bug travels from 3 to 5 in 3 seconds. So that's an increase of 2. So 2 units every 3 seconds is 2/3 of a unit per second. So now we can go ahead and write our formula. The formula says that the x coordinate, go ahead and write this down here. It's a little too big to write in the space. So the x coordinate is equal to, so it'd be our starting point, 2. We start at 2. And then, if we're going to plug in a variable t, we would add in t increments of 4/3 each. So every second is 4/3. So for t seconds, it's t times 4/3 added on to the starting point of 2. 2 plus 4t over 3, which is the same as 4/3 t. For the y coordinate, we start at 3 plus, so for t seconds, for every single second, we move up 2/3 of a unit. So if I want to figure out where we're at after t seconds, I just have to multiply t times 2/3 for 2/3 for each second, so 2/3 t. And of course, we're adding that onto our original 3 points, or 3 units, 2t over 3. So now we have our 2 equations. We can use these 2 equations. I can plug in any value for t, and I will be able to calculate its x coordinate and its y coordinate separately, okay, for any value of t. So we could ask, ourselves some interesting questions here. Could say, well, is the bug ever going to reach a point where it is, say, twice as far from the y-axis as it is from the x-axis, right? So that would mean that our distance from the y-axis is our x-coordinate, and our distance from the x-axis is our y-coordinate. So is there ever going to be a point where the x-coordinate will be 2 times as big as the y-coordinate? Well, so we'd be asking, is it ever true that x equals 2y? Well, if we want to find the time, we have our two expressions down here. So I can substitute 2 plus 4t over 3. 2 plus 4t over 3. And over here on the y side, I'll substitute, I've got my 2 times 3 plus 2t over 3. All right. Then we just work it out here and see if we can solve for t. So let's see, on this side I'm not doing anything yet. 4/3 t. Over here we use distributive property. I have 6 plus, that's 4t over 3. Hold on a second. Okay, I had to think about that one for a second. I just pulled this problem out of thin air and I hadn't really thought it through. And I was suddenly in the middle of my algebra and realized I'm about to subtract 4t over 3 from each side, leaving us with 2 equals 6. And as you recall from Algebra 1, when that sort of thing happens, and they're not true, that means that the equation has no solution. And I was like running out some numbers and playing around with it a little bit, like, oh, it actually doesn't. So this bug is never going to reach a point where it is twice as far from the y-axis as it is from the x-axis. So let's pick something different. Let's pick same distance from x as it is from y. So let's see. That would be when x equals y. Well, this one will have a solution. So that means that there's a point where, here's our parametric equations, 2 plus 4/3 t and 3 plus 2/3 t. So we've got 2 plus 4/3 t equals 3 plus 2/3 t. So we're substituting this expression for x, that expression for y. We're looking for a place where the x and y coordinates are the same, meaning it's the same distance from both axes. Let's see. I will I'll subtract 2 from each side. That leaves us with 1 over here. I'll subtract 2/3 t from each side, leaving us with 2/3 t equals 1. Let's see. Let's see, hold on for a second. So I'm going to multiply both sides times, 3, and that'll give me 2t equals 3, and then divide by 2, and that gives us t equals 3/2, which is 1.5 seconds. Now let's take a look here. Well, 1.5 seconds is halfway between 0 and 3. If you look here, on that journey, halfway between 2, 3, and 6, 5 is this point right here, which is 4, 4, which is the same distance from each axis. So if we want to figure out something like that, we just have to set it up. So same distance from each axis means that the x and y coordinates are the same. So we say x equals y. Then we substitute our two expressions, and then we'll solve for t, and we get a time, which we can look up here and figure out where that time is. And right there. All right. Looks good.